Hello and welcome to the Textbook Engineering Problem channel. We're working on problem 2.15 from Elementary Principles of Chemical Processes, 3rd edition. Let's get started. The problem statement says the Fern is defined as the unit of force required to accelerate a unit of mass called the bung, with the gravitational acceleration on the surface of the moon, which is 1/6 of the normal gravitational acceleration on Earth. Part A, what is the conversion factor that would be used to convert a force from the natural unit to the derived unit in this system? Give both its numerical value and its units. And then part B, what is the weight in ferns of a 3-bung object on the moon? What does the same object weigh in Lizard Lick, North Carolina? I'm not even sure if that's a real place. Interesting. Okay. I think the moon is. I'm just not sure about Lizard Lick. We've got 2.15. We're going to do part A. So they told us in the problem statement that one fern equals a bung per meter squared, defined as a unit of force required to accelerate. Okay, and it's to accelerate on the moon, so yeah, I guess those are the units, and that's the conversion factor. One fern equals these units and this number. Okay, so that means that one fern equals 1.635 bung meters per second squared. So that's a unit of force because a bung is a unit of mass. So mass times length divided by times squared is a unit of force. So then that's it for part A. We are moving on to part B. Right, so we're calculating the force of, or the weight of 3 bungs on the moon. Okay, so the mass is 3 bungs, and the acceleration on the moon is 1.635 meters per second squared. And we need to use our conversion factor in order to convert into ferns. So one fern is equal to 1.635 meters per second squared bung. So these conversions cancel out, and we're just left with 3 and ferns, so this equals 3 ferns. Cool. So that's the first part of what it weighs on the moon. Then we do pretty much the same thing, except for now we're on the Earth. So the acceleration becomes 9.81 meters per second squared. Okay, so let's do the same setup. We have 3 bungs. We have 1 fern. It's equal to 1.635 bungs meters per second squared, and we have 9.81 meters per second squared acceleration, and this meters cancels meters, seconds, bung, we're left with ferns. 3 times 9.81 divided by our conversion factor here, that equals 18 ferns. Great. So that makes sense, right? We've got, if it weighs 3 ferns on the moon, it's going to weigh 6 times more on Earth, so 3 times 6 is 18. Great. All right, so that's the answer to problem 2.15. Thanks for joining me. I hope you enjoyed the video. If you noticed any errors I made, let me know, and I will make a correction in the video description. Thanks.